At station number 2, you're going to find empirical formula of magnesium oxide. These are the equipments. You should have a tripod, a crucible and its cover, a clay triangle, a Bunsen burner, and crucible tongue, balance, and magnesium. This is how you should carry crucible. Be gentle, don't put too much pressure. It will slide, drop, and break. The only measurements you have today is mass measurements. First, measure your crucible, and it's digital, so this is my absolute uncertainty. Crucible with magnesium, and finally, after the reaction is done, crucible with magnesium oxide. I'm going to take these numbers to the next slide, and we are going to crunch them in this fashion that I'm going to subtract the crucible magnesium with crucible. From the empty crucible, you find mass of magnesium, and note that the absolute uncertainties are added. Same story with magnesium oxide and crucible minus the crucible, absolute uncertainties are added. Finally, if you subtract these two numbers, you find mass of oxygen. To find the empirical formula, take and convert mass of magnesium to moles by dividing by its atomic mass. Same thing for oxygen. Once you have the two numbers, divide by the smallest, and I found 1.2 to 1. Then multiply it by a number that you get the closest whole number. And it became 6 to 5. So my experimental empirical formula is Mg6O5, but theoretically we know it's MgO. Now you have to make a decision. These absolute uncertainties are too small to have any argument for random errors. But systematic errors is humongous, because we see it's not Mg1O1, it's rather 6 to 5. These are some possibilities, some of my questions that I'm raising, and then I'm looking forward to see what you say. My questions are: did any of the products escape the crucible while the reaction was taking place? Did all the magnesium burn? And finally, was there some nitrogen that reacted with magnesium?